Guys, Smiley here. So today we are looking at equations in two variable. So in the lower classes we have studied about equation in one variable. So what do I mean by that? Let's say we have this x plus 3 is equal to 5. Right? There is some unknown value of x for which when it is added with 3 it gives you the result 5. In this case, x will be equal to 2, right? And if we substitute this back in, 2 plus 3 is equal to 5, and that's definitely 2. But what if there were two unknown variables, right? There were two unknown value, and that's where our today's topic equation in two variables come from. So let's look at an example right here. Let's say I have a value x plus y is equal to 3. Alright? Now there are many values for this. There are infinitely many values. If I ask for x and y, so first value can be 1 plus 2 is equal to 3. Next can be 2 plus 1 is equal to 3. Next value can be 4 plus minus 1 equal to 3, right? And there can be minus 1 plus 4 equal to 3, and so on and so forth, right? And that's equation in two variables. Let's look at the graph to understand it more. So now we will look at a graphical representation of that. So we have x plus y equal to 3, and this line right here shows all the possible values for x and y for which it will give you an result 3. Okay. Now in a moment we will also understand how did I arrive at this line, right? Like how did I plot it? Okay, but first understand this, right? On this line we can see there are infinitely many points. Why? Because a line contains infinitely many points in itself. Thus from this we can say that x and y have there are infinitely many solutions for this. Okay, so now let's learn how to plot this graph. Okay, so to plot this graph we will have to first input various x values and get some various y values. Okay, so I know it's sounding very difficult right now, but we will say it. Okay, let's say x is equal to 1. Okay, if x is equal to 1, 1 plus y is equal to 3, therefore y is equal to 2. Therefore we have obtained one coordinate, so that is 1 comma 2. Okay, now next, let's say x was 0. If x was 0, y will equal to 3. Therefore we have obtained another set of coordinates 0 comma 3. Okay, so I will write it down here. Now let's say x is equal to 3. Okay, if x is equal to 3, y will equal to 0. We have obtained a third set of coordinate 3 comma 0. And generally 3 coordinates are more than enough, I would say. If you want one more, we can add one more of them. Let's say x equal to 2. Therefore y will equal to 1. Therefore 2 comma 1. Okay, now this is a lot. Okay, and we have obtained them. So now how do we go? Right, let me just erase this line and I will show and redraw it so that you understand it. So now first we will mark the point. Okay, we will mark the points on which of the coordinates which we have obtained, right? The solutions. Okay, these coordinates we are going to point mark them on this graph. So the first point is 1 comma 2. So 1 on the x-axis and 2 here, so it will be somewhere here. Okay, next 0 comma 3, 0 comma 3, that is here, right? Then third 3 comma 0, it's here, right? Then finally 2 comma 1, 2, so 2 on the x-axis and then 1, so here, right? Now what we will do is that we will make a line so that it joins all of the points together. Hear it again, we will make a line that connects all these dots that is the coordinates together, and this will be, so as you can see this is the line right here which connects all the points together, right? And I will just say that this is 2. Okay, we are 4 3 2 1 and this, right? And therefore this is the line which is the equation for this, right? And all the points, right, all the points on this line are the solution for this equation right here. Okay, and that's one method for solving an equation in two variables when you have only one of them, right? But we don't really use this because, right, there are infinitely many solutions for this. However, now we will look at when we have two equations together, okay, and we have to find a common solution between them. Okay, so let's look at that. So now we have two equations here. There is some number x when added with y will give you 4, and that same number x when subtracted with the same number y gives you 1. Okay, now if I ask you what are those numbers, you will have to think, right? And basically to find those two numbers we have two methods. Okay, number one is substitution, okay, and number two is elimination method. Okay, so we have these two methods right here, and we will be discussing them step by step. Okay, so first we will look at elimination method. So how do we use elimination method? In elimination method, what we have to do is we have to eliminate one of the variables from the given equations. So we have this equation number 1 and we have this equation number 2. Okay, from these two equations we have to eliminate two variables, either one of them, either x or either y. All right, now how we will eliminate x and y? We can either add or we can subtract. Okay, we can either add or subtract, and then we can eliminate the variable. Okay, so in this case I would suggest we would add. Why? Because if I add, the variable y will get eliminated. Why will it get eliminated? Because when y is subtracted, please listen to this, when y is subtracted, sorry, when y is added, right, when y is added, what will happen is this y and this y will get cancelled out, right, and we will be only remaining with x. So let's add equation 1 and 2 together. So we will add 1 and 2 together. What we will get is 2x is equal to 5, right, or 4 plus 1, which is just 5. Okay, so from here, this is a linear equation in one variable. We can solve for x. What we will get is 5 by 2. Okay, now what we do here is after we get the x value, we can substitute it in either of the equation. Okay, so we can substitute it in this equation or this equation. Okay, so let's substitute in first equation. So if I substitute this in the first equation, right, so 5 upon 2 plus y is equal to 4. I will do that. I will bring this over to this side. I will get y is equal to 4 minus 5 upon 2. Alright. And this is just an equation in one variable which we can easily solve. So this will become y is equal to 8 minus 5 upon 2. Y is equal to 3 upon 2. Alright. So now we have obtained the value for x and y, both of this equation, and they are valid, that is they work in both of them. Okay, both one first equation and the second equation. All right, now we will look at this type of sums, right, when there is nothing common. So you can't cancel out x, you can't cancel out the variable y, right? So now what do? What we do here is we want to figure out the variable which we want to eliminate. It can be either of the variable. It can be either the variable x, either the variable y, right? So now to do that, what we have to do is we have to make the variable equals. Okay, we have to make the variable equals. So look here, how do we make the variable equal? So let's say I want to eliminate x. So to make x, this 2x and x equal, I will multiply, let's say this was equation number 1, this was equation number 2. I will multiply equation number 2 with number 2, right? I will multiply it with 2, and what I will get is 2x plus 3y is equal to 8. This is equation number 1. And equation number 2, after getting multiplied by 2, right, we'll multiply this entire equation with 2. what we will get here is 2x minus 2y is equal to minus 1. Alright. And now what we will get here is we will have to subtract. Why? Because here is 2x and it's positive. To eliminate 2x, now that we have an equal variable, right, we have some variable that is equal, and when we add or subtract, we will get equation in one variable, right? So if I subtract equation number 1 with equation, so if I subtract first with the second equation, I will get some variable y. Alright, so let's do it. So if I subtract, so while subtracting, this sign will flip, this sign will become plus. Alright, and from here what I will get is 5y. Alright, 5y is equal to 7. Alright, or is it? No. Now why it is a no? Because when I said that we will multiply 2, right, we'll multiply 2 with the entire equation, I was also referring to this minus 1 as well. So this minus 1 will also get multiplied with 2. Okay. And similarly, when we are flipping the signs, alright, when I am flipping the sign, this sign will get flipped as well, and this will become positive 2. So now let's do it. Okay. So if I do it right now, what I will get here is 5y is equal to 10. Therefore, y is equal to 2. That's our answer. Now, I can just substitute this in equation 1 or equation 2 and I will get my answer. Right? So, let's substitute this in equation 1. Alright, I will substitute this in equation number 1. So, x minus 2 is equal to minus 1. This will go there. X is equal to minus 1 plus 2. X is equal to 1. And that's our answer. Now, let's say I have this equation right here. Okay? If I ask you to find this, you will use the elimination method and all, right? But there is one more method which we can use, and that method is called our substitution method. Okay, and now we are going to use that method. Okay, so what we will do is we will substitute a variable y in terms of x. So, or we can substitute x in terms of y. So let's look at it. So let's say I consider this as equation number 2, this as equation number 1. I will just delete this. Okay, and now what we will do, let's take equation number 2. So x minus y is equal to 2. I will put y towards that side. So I will get y plus 2 is equal to x. Right? Now I will take 2 towards that side and I will isolate y. So what I got is y is equal to x minus 2. Okay. I have got that y is equal to x minus 2. Now what I will do is that this y value what I have got, right, this y value what I have got is I will substitute it in here. Okay. So this will become x plus x minus 2 is equal to 4. This is now a very simple linear equation. 2x is equal to 6. X is equal to 3. Right. If x is equal to 3, we can put this in this equation right here. Y is equal to 3 minus 2. Y is equal to 1. Okay. And that's called, and this is the substitution method. Now, substitution method works for every number. Okay. Every type of equation. You don't need to multiply or do any of that. You just have to isolate some variable, right? Y or x or a, b, any variable what you have got, two variables you have selected. You have to isolate either one of the variables. Then you substitute it in either the first equation or second equation. You get the value and you substitute it back in. Okay. There is no need for multiply and all. Okay. On that substitution. So now let's look at this example right here. What we will do is, this is equation 1, this is equation 2. Let's isolate some variable. Let's isolate x. So x is equal to 3 minus y. We will now input this in the first equation. What we will get is 2 bracket 3 minus y plus 3y is equal to 8. Now we will open up the brackets. 6 minus 2y plus 3y is equal to 8. Therefore, y is equal to 8 minus 6. Y is equal to 2. Okay. Once we have got the value for y, we can either input in this or this. Now, why we can do in this equation and this variable, because this is just equation number 2 but rearranged. Okay, so if I put y value here, so x is equal to 3 minus 2, x is equal to 1, and that's my answer. Okay, and as you can see, we have quickly obtained our answer with substitution method also. Okay, you can either use elimination if you're seeing any variables getting eliminated, or we can use the substitution method also. Okay, and that's the two methods for solving equation in two variable when you are given two equations. Okay, now we will be looking at two equations. Okay, so let's say there is some equation x plus y is equal to a, where a is some constant. Now a can be anything, it can be 5, 6, 7 and so on. Okay, it can be minus 1 also, minus 1, minus 2, right, 2 upon 7, any number. Okay, and let's say there is another thing, x minus y is equal to some b. Okay, now why am I showing this to you? Okay, now we will be looking at the graphical explanation of x plus y and x minus y, right? Graphical explanation of these equations. Okay, so when I say that some number added with y gives you some constant, so let's say in this case 5 and this case 1. So if I say x when added with y gives you 5, and some number x when subtracted with y gives you 1, what are the two numbers? On the graph, it corresponds to that there is a line x plus y is equal to 5, and there is another line of the equation x minus y is equal to 1, and their point of intersection, and the point of intersection is called the solution for the equations. Okay, where they both satisfy each other. So let's look at that. So now we have these two equations right here. Okay, so to solve it graphically, first I will take this first equation right here. Okay, I will say that x is equal to 1. So for the first equation, this is equation number 1, this is equation number 2. For the first equation, x, okay, so I will just say that for 1, right, the corresponding sum values are 1 comma 4, right, because when 1 plus y is equal to 5, y will be 4. Okay, next, when x is equal to 2, okay, when x is equal to 2, y is equal to 3. Okay, and when x is equal to 3, y is equal to 2. Now we will do the same process for the second equation. Okay, so for this, so for the second one, okay, for the second one, when x is 1, okay, when x is 1, y is 0. So 1 comma 0. Okay, when x is 2, when x is 2, okay, this is 1. Why? Because if I say that this is 2 minus y is equal to 1, right, this will be y is equal to 2 minus 1, y is equal to 1. Okay, and finally, when this is 3, this will be 2. Okay, now if you look at all the solutions what we have obtained, we can see that 3 comma 2 is common, therefore this will be the point of intersection. But let's solve this. Okay, let's make the line and confirm it really. So first we'll make the points on the first equations. Okay, so what is the first equation's graph? So 1 comma 4, so here, right? Next what we have is 2 comma 3, so 2 from here, 3 here, 2 comma 3. Then 3 comma 2, so 3 from here, 2, right? Here it is. Now let's look at equation number 2. It's 1 comma 0. It is 1 comma 0. So what does this mean? 1 comma 0, it is somewhere here. Okay. Next, 2 comma 1. 2 comma 1 is 2 from here and 1 here. Then 3 comma 2, which is here. So if I draw the line, it will be looking some. So now from here we can look that this line right here and this line right here, they both intersect at 3 comma 2, right? And what is this line? This line is nothing, x plus y is equal to 5, and this line right here is nothing but x minus y is equal to 1. So from here what we have identified is that on a graph, when you are given two equations, their intersection is the solution for your equation. Okay, so where this equation and this equation both have the same x and y value, and that's the graphical explanation for equation in two variables.